Q3d from the Review2 sheet. This has a star next to it because this one is a particularly challenging problem. So there's a few things that we should maybe make sure we're clear on. And one of the things is that when we have expressions to even power, so in this case these are expressions to even powers, we're always going to end up with positive values. Okay, because anything to an even power ends up being positive. So we want to graph this and do our graph analysis on this. So we want to start with our zeros. Now to solve this algebraically, it's going to be very complicated. But we can end up with this expression that looks like this. X minus 1 to the 2/3 is equal to x plus 1 to the power 2/3. Now, if we drop the powers, this is not quite correct because of that even power here and here. So we can do this by inspection by saying, well, what value of x will make these the same? Knowing that this is going to end up being a positive value, this is going to end up being a positive value. Well, if I just look at this, I can kind of guess that if x equals 0, we're going to end up with negative 1 to the power 2, which is positive 1. And then we end up with positive 1 to the power 2, which is positive 1. So x of 1 equals 1. So x equals 0 is a valid solution. So by inspection, I can come up with this x equals 0 solution. Okay, so then we need to look for horizontal and vertical asymptotes. So horizontal and vertical asymptotes. So if I take a look at this, will this have a horizontal asymptote? Sorry, a vertical asymptote. And there are no restrictions, there's no denominators here, so this is not going to have any vertical restrictions to give us vertical asymptotes. So we need to establish there's no vertical asymptotes. Okay, what about horizontal asymptotes? So what's going to happen here? If I let the limit of this expression, x goes to infinity, of that minus that. Okay, as x gets really, really big, the minus 1 and the plus 1 essentially become insignificant. So what ends up happening is we end up with, this is basically going to be equal to x to the 2/3 minus x to the 2/3, and that means it's going to have a limit of 0. So the horizontal asymptote is going to be at y equals 0. So we've established there's a horizontal asymptote. I'm just going to make sure that I keep track of it. I'm just going to highlight that. There's a horizontal asymptote here. We have a x equals 0, 0. So we've got no vertical asymptote. We have a horizontal asymptote. We can move on to analyzing the derivatives. So let's take a look at the first derivative. So the first derivative is going to be 2 over 3 x minus 1 to the negative 1/3 minus 2 over 3 x plus 1 to the power negative 1/3. Now we've got a negative power which is generating a denominator, so we're going to have some restrictions here. So we should maybe state our restrictions. Actually, maybe I'll rewrite this first. So y prime is equal to 2 over 3 root x minus 1 cube root minus 2 over 3 cube root x plus 1. So we need to state our restrictions that x cannot equal plus minus 1. Okay, so we have the slopes are undefined at x equals plus minus 1. So something is happening at those points. Okay, although there's no slope values that we can calculate there. There are coordinates there. It's not an asymptote. So we know that there's something going on there. And I'll show you what that looks like in a second. So let's do the rest of this analysis. So I'm going to solve for that when this is equal to 0. Okay, so we need to make this equal to 0 and solve this. Okay, so I'm going to make it equal to 0. I'm going to rewrite this equation. It's going to be 2 over 3 x minus 1 equals 2 over 3 cube root of x plus 1. Okay, we have established our restrictions already, so I can take them out of the denominator. I can cancel those terms out. So I end up with cube root x plus 1 is equal to cube root x minus 1, cube root both sides to solve this, so I get x plus 1 equals x minus 1. Cancel the x's, so I get 1 equals negative 1. Well, that's not true. Well, what does that mean? What that means then is, when I solve this and I get something that looks like this, means that there is no solution. So there is no point, there are no x's that will make 1 equal to negative 1. That means that there are no places where the first derivative is equal to 0. So I'm going to start doing my slope chart so I can start keeping track of some of this stuff. Okay, so I'm going to use a table of values and slope chart. I have no places where the second derivative is equal to 0. Sorry, the first derivative is equal to 0. However, I have places where my first derivative is undefined. And those are critical points, and we have to test our slopes across those points.